for having me. I'm going to share my screen. Give me a second. So welcome everybody. I'm going to teach this section on Introduction to Open Code. I also had the pleasure actually to contribute to this section as part of the NASA Open Science Top Sprint. And yeah, this is now, I think, this third time that I'm giving this talk, so I'm really excited to be back. So yeah, this slide deck, you can find it online. There should be a link in the Frama pad. You can just click it and it opens in your browser window if you want to follow along. Otherwise, yeah, I think the material can be shared easily. So let me move along. How do I, let me see. No, okay. So the first slide is boring about me. I'm a postdoctoral fellow associated with McGill University and the Donders Institute in the Netherlands. In my daytime, I develop machine learning models to create normative models on large neuroimaging data sets. I also study computer science on the side, which has been ongoing since forever, but we're getting there. In my not day job, like outside my day job, I'm involved in a lot of open source and open science initiative. So I'm the incoming chair of the OSIG, that's the open science group of my field. I'm also part of a group called datatalks.club. They also offer training for data science and machine learning and AI. Like I said, I did the top stuff, and I've contributed to a couple of libraries, and of course the Turing Way, where I'm also at least once in a while member of the or like contribute to the community governance group. And I really like cats, and this is my cat Soxy, who sadly passed away last year, but I thought I'd keep her in the slides to remember her. This talk will consist of two sections. The first one is an introduction to open code. The second part will be how to use and find open code. And it's mostly modeled based on the original Open Science NASA TOPS curriculum. So the learning objectives are you should be able to define open source software and distinguish it from closed source software. List common benefits and challenges to the production of open code and describe how researchers can respond to some of the challenges while maximizing openness when appropriate. Describe the function of and purpose of a software management plan and its utility as a guidebook for everyone involved in a scientific project. Yep. So what is open code versus software? So code is a structured way of conveying information. The term is not necessarily computer specific, as you probably know. You can also have Morse code, for example. There's a high level code that human can understand, and this code has usually need to be compiled into machine language. The low level code that the computer can understand. So there's two levels of code. And software is a bit more specific. So it's kind of a collection of programs, data, scripts, and code that are bundled together and executed together. Software can be open or closed. And then we have open source software that is, of course, specifically opened and distributed with source code without cost, making it available for others to use, modify, and distribute with its original rights and permissions. So basically, code is kind of software, but software is not only code. Open source software is also openly, transparently shared in public repositories and sometimes maintained through collaboration. And also open source software is the basis for a vast range of research software packages. And in science, we often use open software. And it's often protected by a license that governs the sharing and the use of the software. We are going to talk about license this later. Yes. I wanted to start with a history of computing and specifically mention people that are often forgotten or not recognized. So the first ever programmer is a lady named Ada Lovelace, and she actually wrote very interestingly, she joined a circle of scientists that contributed another gentleman called Carl Babbage, and he kind of constructed a machine that didn't work, but Ada wrote the first code or programming instructions for this machine. So she is considered to be the first programmer ever, because she wrote instructions that can be executed on a machine. Then later we have Grace Hopper, who is known for inventing the compiler. So basically how to, she basically made it possible that we can now write almost English sentences to code. Before that, you had to write like very low level code. And yeah, she wrote basically the compiler that translates between the two. Interestingly, her boss was really obsessed with this gentleman, Charles Babbage. So she wrote an instruction manual for the Mark I, one of the first computers that includes a history about Ada Lovelace and Charles Babbage. So it's kind of very interesting that, you know, she was also really interested in this person, actually, in Ada, actually. And then we have Margaret Hamilton, who wrote code for NASA. You see here next to all the code that she wrote that got us to the moon. And then we have Kathleen Johnson, who was a mathematician also at NASA, and she's one of the figures in Hidden Figures. If you want or interested in this person, I would recommend reading the book. There's also a movie, and there's also a biography of Grace Hopper if you're interested in that. Yes. The principles behind open code, a bit of a manifesto. So that is a bit of a wordy slide, but I thought I'd put it all here. So the principles behind open code are transparency, collaboration, share early and often, inclusivity, and community. And transparency. Whether you're developing software or solving a research problem, we all have access to the information and materials necessary for doing our best work. When these materials are accessible, we can build upon each other's ideas and discoveries. We can make more effective decisions and understand how those decisions affect us. So that's transparency. Collaboration. When we're free to participate, we enhance each other's work in unanticipated ways. When we can modify what others have shared, we unlock new possibilities. By initiating new projects together, we can solve problems that no one can solve alone. And when we implement open standards, we enable others to contribute in the future. Share early and often. Rapid prototypes can lead to rapid discoveries. An iterative approach leads to better solutions faster. When you're free to experiment, you can look at problems in new ways and seek answers in new places. You can learn by doing. Inclusivity. Good ideas can come from anywhere, and the best ideas should win. Only by including these perspectives in our conversations can we be certain we've identified the best ideas, and good decision makers continue to seek those perspectives. We may not operate by consensus, but successful work determines which projects gather support and effort from the community. And then community, last but not least, communities form when different people unite around a common purpose. Shared values guide decision-making, and community goals supersede individual interests and agendas. Yes. So then we come to basically what is types of software and what is software. And I wanted to kind of differentiate between different types of software that you might encounter. So there is overall general purpose software that's produced for wide use and can be opened or closed. And that's like software at the level of, for example, the Linux kernel or browsers or the operating system of your phone or your computer. Then there's operational infrastructure software that is used by data centers and large information technology facilities to provide data and services. There will be API, web apps, and these kind of things. Then we have libraries that are generic tools for implementing well-known algorithms, providing statistical analysis or visualization, which are incorporated in other software categories. And these are smaller. So we're basically going from larger software to smaller. You've probably all encountered libraries. So that would be scikit-learn, NumPy, Pandas, and so on. Interestingly, Grace Hopper was also the first one to kind of create libraries. And in her days, it was basically, so they still used punch cards. So she punched the code onto paper strips, and like putting all these papers literally in a cupboard was a library. So she kind of also termed this she termed this term basically, and because it was papers, it's kind of also more close to libraries than what we have now. Then we have modeling and simulation software. that implement solution and mathematical equations given input data and boundary conditions or infer models from data. So here we come probably closer to what you would encounter if you program. So that can be, for example, MATLAB libraries or Stan, so smaller programs. And then we have analysis software, for example, R and SPSS, which you might have used. And then this is probably code or software that you don't only use, but also produce. So that will be code that you write, written for single-use utility software. So written for in your instances, such as making plots for a paper or manipulating data in a specific way. And this code often uses reuses libraries for analysis, plotting, or reading data. And this is the code that you produce, and this is the code that you have power over. So this is the code that you can make open, pretty much. So now we come to our first kind of little exercise. This presentation tries to encourage you to share your code if you've written code. But I would like you to come together. I don't know whether we have enough people for a breakout room, but to think about benefits and challenges of sharing code. So what are general and personal benefits of sharing code? What are general and personal challenges of sharing code? If you've shared code already, why? And if you've not shared code already, why not? And if you encounter challenges, can you think of a solution? Yes. How many people do we have? Should we do it in that big group?
Yeah, I think
Until
we have a small group that we can do everyone in the main room. So what we can do, I can set a timer for self-reflection for like 2 minutes,
yeah.
and then we share. Okay. Please feel free to take notes on the front page if you want, or if you don't want to share verbally and want to share just on the front page, also welcome.
So do we maybe want to start with who has already shared code? Can I maybe get a raise of hands or a reaction? Two people. You can also unmute yourself and say yes. It's also fine. And so I assume the rest either doesn't want to speak or has not shared code. So for the people who have shared code, why have you shared code? And did you have considerations or like what was the reason behind it?
I can start if you guys want. Can you guys hear me or is it too
Yes.
loud?
No, it's perfect.
Okay. So I think one benefit is to improve quality and reduce bugs. Usually you can share your code and other people can find defects on it and try to improve it. Improve reproducibility as well. In terms of challenges, I think the insecurity is one of them. You're exposing your rationale and your in terms of scientists, we tend to like to hide what went wrong and only publish what went right. That kind of contradicts the whole open science spirit. And in my case, I have shared code already because it was part of some of my work is in data analysis and some of my statistical proposals to work with proteomics, if that is in my case. It was kind of something new, so I had to write my own code to do execute the idea that I wanted. Um, and I don't think I have a with withheld withheld code, so I don't know. I never chose not to share code when I had the option to. Um,
Great. Yeah,
okay, I think that's it.
thank you. Graciela?
Yeah, I was thinking on the reasons why I share code, and I think one of the reasons that is not super explicit in my head, but it's one of the biggest reasons actually, is to kind of register what I did. Otherwise, I can lose everything with my backups that are messy. Um, so yeah, it's kind of the same way that I write a paper and the text and the methodology to kind of register what I did. I tend to share code for the same reason to kind of have a documentation of what was done.
Yeah, exactly. Anyone who has not shared code, can you give a reason why? It could be that you've never written code. That's a very valid reason. But if there's any other reason, um, or maybe are you at least considering it? Maybe. Is there anyone who wants to share anything? No, that's also fine. Yeah, I also try to share most of my code. There's sometimes I can't because the code um, is run on data that I'm not allowed to share. Um, so that's usually a problem. I would then share maybe the code, but I cannot share the data, so it's kind of a bit useless. Also, like if I make plots and stuff, there's like sometimes, information in these plots that cannot be shared that easily, or at least like in the creation of these plots. Another reason, of course, is like you said, like the insecurity thing. Like I've definitely shared things where people then email me and say, "Oh, I found this bug," and that has happened actually just very recently with some stuff that I put out there. It's like, "Oh, there's like this. This could be. It was not a major bug, but it's still like it's like it stings. You think like, okay, I tried my best, but apparently it was not enough. Like, yeah, I could have done this better, but yeah." So I can understand the hesitation. Although, like I said, like Ariel said, I think these are the best argument for sharing code. Is like to make it better and to make science reproducible. So yeah, like I can in general, I can recommend. I think sharing is better than like any sharing is better than not sharing. So even if you just create a GitHub repository and dump all your code, which is what I did. That's why it was so bad. It was just literally a code dump. Um, it's better like if you don't have the time to write, to do refactor your code to make it like super nicely usable. Sharing it in any way or in any state is, I think, better than not sharing it. Because in this way, at least people could, interact with me and they said like, okay, we found this part useful, but this part we didn't understand, and then I could help them understanding what they didn't understand. Okay. let's move on maybe. Let me just move you all out of the way. No, that's not what I wanted. I can't see. Okay. Smaller. Yeah, so I've just listed a couple of benefits and disadvantages also here. So yeah, papers with code often get cited more often. That's a fact. There's literature on that actually. You have increased credibility because people believe in your method if they can reproduce it. It's good for your portfolio. So I don't know if some of you, whether some of you think about like maybe a career in software, if science doesn't work out. Like I'm still not sure what I'm going to do with my life. But then you have code, already written code, and like it's out there to see for everybody. The results of your paper are reproducible. You're advancing the scientific progress in general. And then like the challenges, I think we've talked about them, some of them as well. Yeah, maintenance, that's actually an interesting one because it can be quite an effort to keep up with keeping code in a good state. Even, if the code is good, like sometimes there are like updates in dependencies or downstream libraries, and you need to keep up with that. And it can be quite challenging and quite a workload actually. That is maybe not that you're not paid for in your scientific job. There's the fear of getting scooped. I've heard that as well. Like if you put your code out there and it's related to a paper, then others can just redo what you did. And the fear of errors in the code. We've just talked about that. And it's more work, of course. Like I said, a lot of the open science things that we do or like that we would like to do is usually not the things that we get paid for or that our supervisor wants us to do. Like our supervisor usually wants us to, or at least me, to write papers and not necessarily to make my code very beautiful. So there's kind of a bit of a tension there. Yeah, so if you haven't shared code, there's a very simple way to get started. The main code sharing platform these days is GitHub. And you can start by creating a GitHub account. You just click this link and sign up. Yeah, if you commit code, like I said, or share code, it's good to try at least to make it really structured and well documented. Although, like I said, I think sharing the code is better than not sharing in any way. You can upload it to GitHub and create a short README. I'm going to talk about that later as well, describing the project and the execution of the code. So the README is basically the first file or the first thing that visitors see when they navigate to your GitHub repository online. And it describes usually a bit like the repository and what is in there and what you can do with it. It's also always good to add a license. We're also going to talk about that later. And you can also share your data if possible. However, data sharing is usually not possible via GitHub. And I think you have like another session on that. But that's always also good to share at least some data with your code. And I have an example here. Let's see what I linked here. Yeah. So that's my some of the code to my paper. And you see like I basically just dumped here my code, and then I just wrote a very, very brief README because I didn't have more time in that case. Okay. So there are also reasons why not to share code. And you should take these reasons into account and be aware of them. And some of these reasons include the code contains personal data. So I work a lot with clinical data, and sometimes we have like information, even if it's like the names and the sensitive, most sensitive data is removed. Like sometimes I work with data where the disease that I'm looking at is so rare that you could still potentially identify people if for example, where they live and what the diagnosis is. So that's one of the cases where you shouldn't share data. Another one is this is all from the NASA TOPS curriculum. I'm not sure whether many of you will be in this situation, but the code incorporates countries' military secret or disintermination, whether it's national interest or security concerns. And of course, you also shouldn't share the code, but I hope that your supervisors will let you know if that's the case for you. Another reason is that the code incorporates intellectual property or patent data and information. So if you have a patent on whatever you've produced, you also shouldn't share it before the patent is through. And there might be institutional policies or organizational regulations that do not permit the sharing of the code. For example, I often use data from consortia where you need like a specific data usage agreement. And if you've signed that, you can at least not share the data. You might be able to share the code, but that's another reason that restricts you. So yeah, then licensing, and this is actually an interesting one because you should always license your code. And the reason is that if you don't put a license on your code base, basically what happens is that the contribution that has been made belongs to the person that has contributed. So if you have a GitHub repository and you put out code and someone else contributes, for example, then the contribution that this person made belongs to them if there's no license. And that can lead to the case that even if it's your repository, you cannot make changes to it anymore unless you ask that person. So it's better to have a license that kind of in general regulates who can contribute to your code. And then you don't run into this situation, but you can literally lock yourself almost out if you don't have a license. And there are different types of license. And they run from very left, so very permissive to very right. So that would be very restrictive. And you have, for example, public domain licenses that grant all the rights. And for example, CCO. There's then a bit more permissive licenses that grant use rights, but for bits almost nothing. So it even allows closing the software. And there's a copyleft, so that would be grants use rights, but forbids proprietization. So it means that you put the code out there, but it needs to be needs to stay open. You can do anything with it, but you cannot make it closed. And then there is traditionally licenses. So for example, your MATLAB license, for example, where you need to buy access. And there is, I'm not sure whether I have that here. No, I don't have. Yeah, here. So here, there is a bit of information of that, and also I'm not sure whether I included that, but there are so-called license guides. So basically, GitHub, if you type license and if you add a license, it will give you it will guide you to a little tool where you can make like a little like decision tree what you need for your license, because like we are all not lawyers, but there are basically like little tools that help you decide basically like, do you want this or that? And you can click and then you end up with a license that suits your needs. I personally usually give very permissive licenses, but with the condition that anything that I produce needs to stay in the open domain. So I do not want any software company to just come grab my stuff and then sell it. With anything else, I'm happy. Yeah, so another thing you can do is you can make your code citable. So there's a file called citation .cff that you can add to your repository and just put there how you want your code to be cited, or if it belongs to a paper, for example. Another way to share your code or make it citable is to create a digital object identifier for your repository, for example, using Zenodo. If I had more time, I would walk you through this, but it's really not hard. You just need a Zenodo account and you can link your GitHub account to your Zenodo account. And if you create like a version of a release basically of your code, you can archive it on Zenodo, and you get a little badge that you can put onto your GitHub account. Yes. So another thing that you should know about is maybe software management plans. And one of the reasons is that many grant agencies, if you want to get funding for your code or for your project, require you to provide them with a software management plan. This is one from the eScience Center in the Netherlands, and it has like different subsections, and it requires you to think very thoroughly about not only what do you want to do with your code, but also like, what happens when the funding runs out? Like who maintains it beyond, for example, you being at this institute. So it's kind of a push towards sustainability, also kind of in this code section, and tries to prevent, the code being dependent on one person or one funder, and then being unusable or like decaying, for example. Yes, exactly. So the software management plan is a document that describes how a specific software project is developed, maintained, and curated. It's written by the developers, maintainers, and other stakeholders of a software project. And the goal of an SMP is to ensure that the software is usable and maintainable in the long term. Yes, so then I wanted to talk about open code in the time of LLMs. And I think this is one consideration that people have maybe with code sharing that we actually didn't talk about. Is like, is this code going to end up in the training set of an LLM? Which is likely. So we know all that we put code onto GitHub. I don't think, I think you can actually opt out on GitHub. You can opt out, but your code, if your code is forked by someone who hasn't opted out, then it's still in the training set. So I'm not sure whether it's, you have much choice at this point. But yeah, we know this is like code has all ended up in LLMs and is trained on our data. Sometimes there is an opt-out mechanism, but like I said, I'm not sure how much use it is at this point. Yes, you need to be aware that feeding anything into an LLM in a chat, or also if you give them, through the terminal access to your disk, will most likely end up at the training set. Then we have the issue with like LLM generated code. So code generated by LLMs is not clearly copyrightable. It's kind of a bit unclear who's the author, and I think the current there's no current legal solution for this problem because it's new. And using LLM generated code in a licensed repository raises unresolved legal questions. If you use LLMs to generate code, you should declare that when necessary. Yes, and then should you use LLMs for coding? I think yes. It's a clear yes. I think this is the future, and there's no way around it. And it's better that you know how to use it and what the risks and the benefits are. So I would recommend getting yourself familiarized with LLMs and like also LLMs for coding for your work and your projects. The really beautiful thing about LLMs, in my opinion, is that they're new. So if you enter any field, you usually meet people that have at least 20 or 30 years experience. In this field, like LLMs, this is not the case because LLMs are only 3 years old. So if you learn to use them, you can actually be the expert in that field very easily. So this is, I think, why it's a great opportunity for our generation also to become the expert in something. It's kind of being at the time when the first computer came out, like, all these people that learned programming with the older computers, they're now experts. We can never catch up to that, but we can be the experts in this. Further, LLMs are fantastic teachers. So I would recommend using them not as like having them generate your code, but like having them explain you things that you don't understand. These are prompts that I use. You can also, for example, if you find a really beautiful graph, copy it and paste it into the LLM and like say like, give me code to reproduce this graph. Like what was used to create this graph, for example. You still need to own your code. If you use LLM generated code, the minimum expectation is that you are able to read, understand, and explain it. So you have to be able to talk about it as if it was your code. You also have to be able to maintain and to debug it. And then, of course, you never passed sensitive or patient data. So that's kind of, I think, like, yeah, anything that you wouldn't put on the internet, like pictures of people that is not you, anything sensitive, credit card information, email addresses of you and others, specifically of others, never go into an LLM. Um, another good, however, another benefit of LLMs is it can also level the playing field. So if you don't have a computer science background, but you have a great idea, you can use it to write you some code for it, for an app, for example. Similarly, if you have computer science background and don't know about neuroscience, you can use it to tell you about neuroscience, for example. If you want to get started, I included a couple of that I think are great resources. So there's a 5-day LLM course by Kaggle. It's pretty deep. It has white papers about the functionality and how LLMs work actually under the hood. There's an AI for research course that is at the moment on. It's very good. I would recommend checking that out. There are the the club courses. They're free Zoom camps that you can watch or like join. Yeah, and I think that's it. Yeah. Yes. So another thing that I've been thinking about is actually the tension between LLM and openness. Because we kind of have this problem that LLM output is probabilistic and not deterministic. So if you write the same prompt, it's not necessarily doesn't necessarily give you the same answer twice. Um, uh, Yes, so LLM output is dependent on a couple of things. The first, of course, is the training set, but the second one is the context. And the context is usually a set of tokens that the LLM output is conditioned on. Most of the time, it's your chat, your previous chat history, but it can also be any file or any information that you give the LLM with your prompt. And this changes the output. And then we have the context window. Like I said, this is the amount of context that an LLM can keep in memory. Basically, it's usually around 4,000 tokens. So if you provide them with really long documents, it's usually the case that the prompt cannot be generated on taking all of this into account. It's going to be a subsection of it. Yes, you can share the chats of LLMs. You can also share the context, but even that does not guarantee reproducibility. And yeah, this creates a genuine tension with open science principles of transparency and also replication, because we don't really know how this, response or code was created. What was the foundation? What was the condition that it was created? The context that it was created under. So what helps? You can share the code itself, not only the prompt. I mean, it's kind of clear. You can pin the document the version used, so like the model that you used for generating your code or whatever, and testers could describe what it actually does. Yeah, sorry. And treat LLM generated code like code from Stack Overflow as a useful starting point, but you're responsible for understanding and validating it. So yeah, now I would like to know how do you use LLMs? How or do you use LLMs for coding? So do you use them? If so, how? If not, why not? What benefits and challenges have you encountered? And does the openness and LLM conflict or complement each other? Or do you have any tips to share with others? And I think we can do this again in maybe our little group. Any ideas?
Yeah, I will share the chat realigns 155. If you scroll down the front page, there is space for notes there. I can set a timer for self-reflection. What do you think? And then we share.
Yep. Yeah,
Okay.
sounds good.
3 minutes.
Okay. Does anyone want to share? I know Ariel uses LLMs.
Well, I can start. Well, I do use LLMs for coding, and I use LLMs all the time, different models, different harnesses. I work with it all the day. Um, and usually because I'm a bad programmer, I mostly know how to read and understand the code, the logic, and the architecture, but I'm not really good at actually writing the code from scratch on my own. So I usually know what I want to do. I search for someone that has done something similar to what I want to do in another area. I refactor it, and then I use LLMs to go over it, try to catch bugs and to try to integrate that new module that I created with other ones based on contests or on what is the area that I want to use it. Well, for benefits, I if I had to do it on my own, I wouldn't be able to. There would be a really steep learning curve for me to actually begin to produce the codes that I need for doing my job. And I can come up with all different crazy ideas and try them fast to see if they work or not. It's something that would usually take weeks. And challengers is it is a probabilistic model. So uh, I the less fine tuning, the less context I give you may be good for some creativity. But it can produce hallucinations and things that are not well structured, which in science is a no. Um, I don't think the openness and LLMs conflict. I think they complement each other. I just think that we have to be really strict in recording what we are doing exactly, because most of them are deep neural networks that kind of work like a black box. So you really need to try to register what you did before and what the output was after, so we can try to reproduce it as close as we can. And for tips, I think you have to experiment. It's all of it is moving too fast for us to wait around to see what will come up from it. So the faster you try to dip your feet in the water, the better you are from when actually everything solidifies in, I don't know, 5 to 10 years from now.
Yeah, I 100% agree. Uh, are there any other ideas, voices? Also, maybe like concerns? I know uh, some people don't really like LLMs, and it's also understandable. Like it can be scary. Like the feeling that there's something that might actually, be much better at the things that you're paid to do. At least in my case, sometimes. Are there any other uh, opinions? Yo?
I don't know if anyone else has experienced this, but I can be very quickly frustrated with privacy leaks. So, for example, sometimes if you want to talk about something in a safe environment, you say, let's not record it. I say this on recording.
Mm.
Um, and then you'll have scenarios where someone will say, like, oh, yeah, so I put that into Gemini and now it's done the thing for me. And we're like, but we were supposed to not be telling, like, there's a difference between working openly and letting everything hang out, right? I'm not walking around naked either. I guess I'm trying to say that sometimes I feel like people don't understand the boundaries, but I'm terrified that I'm accidentally feeding the model when I may have agreed not to.
Mm. Yep. Yep. So yeah, I don't know. I've played a little bit with it, and sometimes, there's not these skills thing. So basically, you give the LLM like instructions that it needs to read with every prompt, for example, and it doesn't always do it. It doesn't always comply with the skill, Sometimes it just ignores it. So the question is like, they just give it access to this folder. Does it really just have access to this folder, or does it sneak out the information? Yeah. Casiel?
Yeah, I think in terms of tips, well, I tried to use LLMs for coding like in the holiday season. I was doing nothing, I was trying things. I got really, it was a complex feeling because the LLM was doing every typing and everything. And at some point, I would even think, even if I knew the code that I wanted to write, I would even like just let it autocomplete itself. And it was a really bad feeling for me because I felt like I was not doing the code and writing the code. And I was getting very lazy. I was getting like, I could do that, but I won't because there's someone else or like a thing doing that for me. Um, and then I discussed that in some groups, and they said that they felt the same and it was not a good feeling for them. And so they just started to, because nowadays you have those AI things implemented within the IDEs, within every software that you use. Um, and so it's hard for you to have agency of when to use that. And so they have this tip of avoiding having the AI things inside your softwares and just have another window for that. And then you move things there if you want to and if you need to. And so it kind of creates a little friction that makes you actually work on the thing before you delegate that to an LLM. So I think that's one tip, especially if you're learning, that could be really helpful.
Yeah, yeah, I read the other day an article about AI brain rot, which is probably exactly like the feeling like you at some point you're just like, no, I don't even want to think about this. Like, just this is what you gave me is wrong, but fix it yourself. I don't want to wait and yeah. No, I 100% agree. Like I say, it's you need to be careful and manage basically. If you do it right, you need to carefully manage what the LLM should give you, and that you still have like basically you're still managing the LLM and not just hand over the task. Interestingly, I've experimented a little bit with some tools. For example, SpecKit. You need to it allows you write several skills that allow the LLM to build a project, for example, but it requires you to upfront be very clear and also aware of what your project should look like. So it actually requires a lot of work and also a lot of expertise to prompt the LLM correctly. So I think that will be the right way to do, and I don't think it will resolve. It's not that we hand over the task; it just shifts like our concentration and our how we work basically. It will require much more upfront knowledge, for example, and also more expertise to correct the LLM. That's what I think. I don't think it will actually replace us because LLMs are just inherently stupid. Anyway, yeah. I think for the sake of time, we should move on, but it's an interesting and fascinating discussion. Also, like what it does with society and like us as humans, I think. But let's move on maybe. If there's no other opinions, let me just. Yeah. So this is the summary of this section. Making software more open has benefits and challenges, which are related. Just greater benefits typically come with greater challenges. In most cases, individual scientists and society will both benefit from more open software. And LLMs can both accelerate and hinder the coding process and might create a tension with reproducibility. Not necessarily with openness, but I think with reproducibility, at least for now. So the second section will be about using open code, and it will be a bit shorter. And the learning objectives are describing the process of using open code and know some key repositories to find open code. Describe how, where, and under which circumstances what should acknowledge or cite code. And yeah. So what are these locations where you already know where you can find code? And probably you've already come across some of them. GitHub. GitHub is, no, I'm not going to open this. We don't have that much time. But it's basically a massive repository of repositories where you can share your code, but you can also just look for code that people have shared. And it's really a great resource for a lot of things. not only code. Maybe I can show some of my favorite repositories later if we still have time. GitLab is a more I think more European also, a European version of GitHub. It allows you to share your code more locally, but it's pretty much this has the same functionality as GitHub. Bitbucket is similarly a code sharing platform, but it's much smaller. There is a website and a repository called Papers with Code, where you can submit a paper that has code, but you can also look for other papers that come with code, which is sometimes really nice if you're interested. Like, if you look in papers with code for like papers for your field, they all come with the code, and you can look up how things are implemented. Then we have the Journal of Open Source Software, which publishes code. So I'm one of the editors there, and the submissions are code-based. So the actual paper to JOS is usually a page, one PDF page, and the focus is really on the software. So that's also a great resource, and like when you want to find good software, because it has been peer reviewed. There's Stack Overflow, which is probably, it used to be the go-to place for software. Now I'm not so sure anymore, but keep using Stack Overflow because we need content for the LLMs. Another way is looking at packages. You can also see there how they're written, and you can learn from that. And then this is one of the coolest repositories, I think, is on GitHub. But you have the Apollo 11 code, the code that got us to the moon. And it's just there. It's written in assembly, both for the luminary and the Comanche. I think one is the little kind of car, or like the little thing that went on the moon. The other one is the spacecraft. So they had kind of a little the kind of car, or like the little thing where the people went into on the moon, but the other one is the spacecraft. And yeah, it's all there, and you can look at it, and yes, it's pretty cool, I think. There are other repositories. So there's the Software Heritage repository that contains old software. There's repositories for specific languages, for example, Python and R. And for free and open source software hub, that's more like all sorts of software. You can check these out. This is like Perl. And now we come to README. So the README is I guess there's the README. The README is a term that is often used within GitHub or Git, but you can also create a README for any repository. And usually the letters README in a file tell anyone who visits this repository, whether it's on Git or not, that this is something they need to know about this repository. So you can create a README for literally anything. And a good README includes a title and description, what the project does and why, installation instructions, dependencies and setups, a usage example. For example, how can you use this code? If you show code to a paper, describe how it should be used to reproduce the paper's results. Citation, how to credit the software in a paper if applicable. Downloads, releases, and changelog. If applicable, describe how to get the latest version and what is changed. So this is more specific to GitHub. And who has worked on this project. Yes, and then the license. We've talked about that. So like there's these two are a bit like sometimes people confuse them, but there's the contributors and acknowledgers, like people that have created the software, and then there's the contributing info, so the contributing MD. How can people contribute to this workplace, to this project? So in the future, basically. And the rule of thumb is when new lab member or someone else who comes in cannot run your code from the README alone, you need to put in more work. And I've put down some resources here. There's like a repository called Awesome README on GitHub, where you can find some examples of awesome readmes, and also like a couple of tips on tools how to create good readmes. Yes. Then we have citing, open code, source code, and software. So the question is like, when should you cite code or software that you use for a paper, for example? And the rule of thumb is that it needs to have played a critical part in your research, provided something novel, or it impacts the results of your analysis. So for example, I do a lot of neuroimaging research, and the tools that we use to pre-process the data can have an impact on the results. So in order for someone to reproduce this, they would have to know exactly what pre-processing tool I used. So I need to cite that in my paper. Yeah, so that's basically saying this. So if you run a simulation using a specific software package, cite that package. You do not need to cite the word processor you used to write the paper, because that is not relevant to reproduce the results. However, if your research is on comparing word processors, then you need to cite the word processor. So that's kind of how you decide basically. Look at what your research or your focus is on. Then I have from the Software Sustainability Institute 10 tips for citing software. Describe any software that played a critical part in your research in enough detail for a peer to repeat and validate what you did. Options for citing. So that's kind of a bit of discussion, because people don't often know where to put it, but it's better to put it in your paper at any spot than not put it in your paper. So can be footnotes, acknowledgement, method sections, and appendices, sorry, a real citation. A license may place you under obligation to attribute software. So there's software that you actually need to cite. There's no way around it. Cite papers that describe software as a complement to, not a replacement for, citing the software. So often there's a paper about the software, but it's actually really important that you cite the software itself, because A, the paper might be outdated, and B, the software developers are often not the people that write the paper. So the software developers need the citations themselves to get funding, for example. In the first draft, always put the software citations in reference or bibliography. So make it a real citations. It only says here in the first draft because the journal might actually come back and say you can't cite the software in the reference section. You need to cite it differently, but always try. And be prepared with reviewers that you want to kind of defend, that you want to acknowledge the software's authors. Or like let them know that you are legally obliged to cite the software. If a reviewer disagrees, you can still make a general reference in the paper. Sometimes if you go to the citation.cff on GitHub, the citation might lack detail. For example, it might not comply with a standard that you need to comply to, for example, when you write your paper. So you might have to add more detail yourself or change the citation format. And if the software has a DOI, use it. Otherwise, use the software's URL. And now we come to citation formats. So this is how you can cite a software. So if it's purchased off the shelf, which is rare these days, it would be product name, version, release date, publisher, location. So it's an example. From the web, it would be product name, version, release date, publisher, location, DOI or URLs, download date. This is also an example. This is more likely that you checked out software from Git or a public repository. Product name, publisher, URL, checkout date, repository specific checkout information. So this would be like, for example, you named a branch. On GitHub with a DOI, author, product name, version, DOI. This is also like sometimes there are different citation formats. And then, so I found this and I added this year. You can now also cite AI tools. For example, Anthropic, Claude for Sonnet, so that would be the model. And then a DOI or like a URL. And you can also actually share AI chats So if you had a conversation with an AI in a GUI, you can share that. And there's also ways to cite that. Interestingly, this is from the API manual, and they have just added how to cite AI tools. And this is now gets us to our last exercise, and I think we're almost at the end. Should we do the exercise, or should we have like a discussion or a Q&A?
I think we have some time to do the exercise. I think we can have like 10-ish minutes, or how much time do you think folks will need to do the exercise?
I don't think too much. So you can pick one of them. So it's 2 exercises. You can pick one of them. The first one would be if you haven't shared code, excuse me, one concrete first step towards sharing code. So what would be the next step to make your code shareable? The other one would pick your favorite software package and look up how you can cite it. And this is dear to my heart because software developers need citations. Yeah. Well, maybe we could just give like 2 minutes and then have a share it how it went and what people's thoughts are. Okay, I think the timer's up. Any feedback? Any share outs? Which one did you pick? Ariel has already shared the code, so I mean it's also okay if people want to think about this later or do it later, I think. But yeah, especially like the citing research software, I think is important. You will realize that if when you know have your own software that you want to promote, how important it is because unfortunately, people, the funders, do not really care too much about you know your community or like if you have a nice Slack channel where people interact, they want to see that your software was cited. They want the hard numbers, and yeah, so that's really what helps software usually. Yeah, so this was it from my side. Like I said, these slides are reproducible. The entire or most of the content is in a much larger form in the NASA TOPS or like the OLS curriculum. So there's like a written version of it. I took some of it and added my own spin, but most of it is there, and there's also more content. So I had to actually pick and choose because the module is quite large. Yeah, but this is it from my side. If you have any questions, could have like a bit of a, I don't know, but what's the plan? Do we need to have like do we want to have a Q&A or
Yeah, now it's Q&A time. If folks have questions, concerns, comments, that's the time. And then we have just one quick announcement before we go.
also like maybe just a comment, like I know the slides were at some point like a bit wordy, but the reason is that it's actually quite hard to add images to. So this is all, the slides are all code. It's basically one long file that compiles, and it's much harder to add images than in a PowerPoint, for example, but it's reproducible. So I will try to add more pictures for the next time, but yeah.
While people think on questions, I have a comment. I think most of the things that we discussed today about sharing code is also applicable to all open projects. So thinking on how you're going to share your documentation for your project, how you're going to interact and invite folks to collaborate and to cite other folks' work. So even like we have these calls before and people are like, oh, I don't do code for my project. My project it's all like documentation or writing stuff. And yeah, so same thing apply here. So thinking about how you're going to make your project public facing, and yeah.
100%, yeah. Yeah. You can also use GitHub for text files, like any text files. So yeah.
All right. If folks don't have any questions, well, you know where to reach us. We are on Slack. You know, Johanna has, I think, some coaching sessions already, still left.
Yes, I have one more
Yeah.
code. So if there's anything
There you go.
you want to discuss, also like around code, which is more my expertise, but also around other things where you might it might happen that I can't give you an expert answer, but happy to chat always.
Awesome. Perfect. Thank you. And so my announcement is just pretty much that. We're going to have a next cohort call on May 7, 2 days, about open code as well, like the second part. And if you want to sign up for coaching sessions, please do so by Friday using, let me copy that, the link for signups on the front pad line 246 Let me copy that in the chat real quick. There are still a few slots left, and we are trying to confirm with experts 3 days in advance. So please sign up by Friday so we can confirm the Monday and Wednesday slots. That's it, I think. Thank you so much, Johanna, for this amazing session. That was great. Thank you all for coming. It's always refreshing to have a cohort call.
Yes,
Right.
thanks for having me. And yeah, please feel free to reach out if there's any questions.
Awesome. See you on Thursday. Bye.
Bye.